Assalamualaikum to Dr. Noriliza. We are from group number 23. We'll present about experiment E1 jar test. Before that, I would like to introduce the member of my group. My name is Azban Syah bin Hamdan, and the rest is Muhammad Darman Nasrul bin Marali, Mr. Jurina binti Kasim, Mr. Razia binti Darwis, and Muhammad Syaril bin Awang Dinin. Thank you.
Introduction. A laboratory procedure that simulates flocculation with differing chemical doses. Jar test is a method of mechanically and physically testing chemical treatment on samples of wastewater to determine the optimal chemical treatment and the related chemical dosage for a specific water or waste stream. The purpose of the procedure is to estimate the minimum coagulant doses required to achieve certain water quality goals.
I Jurina binti Kasim. Now I will continue objective of jar test. Objective of jar test is to determine the optimal dose which will produce the highest removal of a given water turbidity. Equipment: 1 volumetric flask 1000 ml. Second, analytical balance. Third, coagulant and coagulant eggs. Fourth, magnetic stirrer and is optional.
Procedure: prepare the sample. First, collect 3 to 4 gallon samples of untreated wastewater from the equalization or holding tank in a clean 5-gallon bucket. Second, measure 400 ml of untreated influent wastewater into 4 600 ml breakers, label A, B, C, and D. Stir with magnetic stirrer at medium speed or use gang stirrer at medium speed. Coagulation. Step 3. Using a clean 1 ml syringe, add 0.1 ml of the 100% solution of each coagulant being tested. Mix for 2 minutes at medium speed. 4. Add 0.10 ml of aluminum sulfate or existing inorganic metal salt coagulant. Mix for 1 minute at medium speed. After stopping the mixer, look for small particles in the wastewater referred to as microfloc particles. These particles are a sign of a broken emulsion. Step 5. If the sample do not exhibit microfloc particles, repeat step 1 to 4 until microfloc particles are produced. Keeping in mind that no more than 0.5 ml of metal salt coagulant should be used. Exceeding 1000 ppm of the metal salt coagulant will generate excessive sludge volumes. However, it is permissible to exceed 0.5 ml of coagulant being tested. Step 6. Record the volumes of ml of each product used to produce good quality microfloc particles.
For the flocculation, using a clean 1 ml syringe, add 1.0 ml of the 100% solution of each coagulant being tested. Mix for 2 minutes at medium speed. Add 1.0 ml of aluminum sulfate or existing inorganic metal salt coagulant. Mix for 1 minute at medium speed. After stopping the mixer, look for small particles in the wastewater referred as microfloc particles. These particles are sign of a broken emulsion. If the sample do not exhibit microfloc particles, repeat step 1 to 4 until the microfloc particles are produced. Keep in mind that no more than 0.5 ml of metal salt coagulant should be used. Exceeding 1000 ppm of the metal salt coagulant will generate excessive sludge volumes. However, it is permissible to exceed 0.5 ml of coagulant being tested. Record the volume of milliliters of each product used to produce the good quality microfloc particles. Adjustment of the pH may be required to achieve coagulant or emulsion breaking. If no emulsion break is observed at the current pH, adjust the pH to 4 to 5, then begin the jar test produced at the coagulation section. Adjustment of the pH may also be required to achieve flocculation. If no flocculation is observed at the pH after coagulant or emulsion breaking step, adjust the pH to 7 to 10 period